so nice to be here. This is my very first time in Hershey, Pennsylvania, and it's been delightful so far. How many of you live in this city, I guess? Hershey, a city? Yeah? Okay. Great. I kind of like to just do a quick introduction of myself. I know you have my bio, but things have updated a little bit since I submitted that. I've actually made the decision to go back into the schools, so I am a school psychologist right now for the St. Paul Public Schools. I am still teaching classes at the University of Wisconsin in River Falls. I promise I did bring all of my skills and knowledge with me from the university, so I also just bring a little bit more school-based, more recent school-based experience, I guess, with me as well. And so I would also like to hear about what you all do. So can I see a show of hands for elementary school teachers? Ooh, so many of you. Excellent. Okay. And does Pennsylvania, is it K-5, generally speaking, for elementary? Depends. Great. Okay, that's my favorite response, by the way, when anyone asks me a question, because it does, right? It so depends on your building, on your district, on so many other factors. Okay, how many middle school? Roughly 6 to 8. Okay, a few. Any high school people? Secondary? All right, that's okay. How about school psychologists? Oh, only one of you, okay. Oh, 2, 3 maybe? All right, great. Well, it's so good to see you all. Thanks for coming out on this early morning. 8 o'clock is early, no matter what, even if you're used to working. The building I'm in right now is an early start school, which means I'm there at 7:15 with my children, and it's tough. It's tough, but it's okay because we're done at 2 o'clock. It feels like I have my whole day ahead of me, you know? All right, well, our agenda for today is, I know this is an MTSS conference. You are all very well aware of MTSS is, but I want to just ground us quickly this morning and orient us into the work that I'll be talking about and kind of how I conceptualize MTSS. And then we'll just talk a little bit about what those foundational skills are that our students need as it relates to math and fluency building. I'll give you some suggestions for intervention and how to structure your instructional time and use that instructional time to include some fluency practice. And then I'll touch very briefly on progress monitoring because I'm a school psychologist and we love data, right? You all love data, please? Thank you. Okay, good. Not everyone does. It's okay. All right. I will leave time at the end for questions, but if you have a burning question or if you need clarification on something I'm speaking about in the moment, please just wave me down. This doesn't have to be super formal, but we will have time at the end for questions as well. All right. So when I think about MTSS, this is where I like to start. I like to think about us not only using a prevention framework, but really shifting our thinking from that previous model of what about the student is causing the problem. Why isn't the student learning whatever it is we want to have them learn? Why is the student behaving in a certain way? And I try to get the teams that I work with, the students that I teach, and challenge myself as well to really shift my thinking into a place of what is it about the interaction of our curriculum, our instruction, the learners around them, and our overall learning environment, our school environment, that could be altered to better support our students. So that's really what we're going to be talking about today. What can we, the adults, do to support the math learning of our students? Not how do we, what's wrong with this student? What's going on with them? They must have a disability or there must be something wrong with them. So I really want to challenge you all to shift your thinking a little bit, at least for this session, hopefully longer, in thinking about what is it that we can do to help students learn. All right, you've all seen the pyramid a million times. Our triangle is your favorite shape. It seems like that's educators' favorite shape. We have triangles for everything. I like to show this model because it includes the 3 tiers, of course, but it breaks out tier 1 into two. So I break it out into core instruction, right? That's kind of what we traditionally think about as tier 1. What is everyone getting? What does our core look like? But I want to include a class-wide supplement or class-wide intervention into this, right? Our Tier 1 intervention. In the St. Paul Public Schools where I'm now at, they are doing this really strange thing, and I'm just, trying to get acclimated right now. I'm not trying to ruffle too many feathers, but I'm making a little mental list of the things that I want to push back on a little bit. And one of those includes we are doing Tier 1 intervention, but we're not counting it toward student progress. It's very strange. They're saying, well, that's not intervention because everyone gets it. But it is, right? It is intervention. If a student is getting title support, if a student is going with we call it WIN, what I need now. So if a student is getting that support, to me, that's intervention, right? That's something extra beyond, or it should be something beyond what the core is. So that's how they're conceptualizing it. We'll get there eventually. But that's really kind of this class-wide. So how are we addressing those foundational skill gaps with whole class intervention? And how are we monitoring progress for our students? Here I suggest weekly that we're monitoring all of our students. Has anybody ever used PALS or heard of PALS, K-PALS, something like that? Okay. Yeah, so that's an example, right, of our Tier 1. That's something that we're doing with our whole class, but it's intervention, right? It's not part of our core exactly. We're targeting something a little bit different. Okay. So we get into this a little bit more, we do have some good data to show that class-wide intervention does lower what we call our base rate. I won't get into all the psychometrics, mostly because I don't fully understand it myself, if I'm being totally honest. I'm not a measurement person, but what I do know is that when we have high base rates that of a certain thing, it makes it more difficult for us to effectively screen our students, right? Where it's not as easy for our measurement tools to pick up the students that are really at risk, because everyone looks like they're at risk, right? Or no one looks like they're at risk. We don't have very much variability in the data for our students. And so by doing some class-wide intervention, it lowers our overall base rate, and it helps us to better identify those students that are truly at risk, rather than those students who maybe just haven't had the instruction or the support that they've needed to get the skill. Does that make sense? Okay. So we know that this is important, that class-wide intervention does support this. We also know, in looking at mastery in class-wide interventions, that, so the blue bars, if you can't read that, show classes that moved on without reaching mastery on a class-wide intervention. So they're doing class-wide, but maybe they're moving on before everyone's reached mastery or before the majority of the classes reached mastery. And then the orange bar shows those classes that did reach mastery on a particular skill before moving on. And what we see is that the probability of mastering future skills goes up tremendously when we make sure that our students in our class are reaching mastery, right? So we see 35% of students, 35% probability, I should say, of mastering those future skills when we ensure mastery for our class, and 100% when we first master those skills. Similarly, if we look at the percentage of the skills mastered overall, we have 43% for those classes that moved on before reaching mastery, and 69% for those that waited for mastery. So pretty powerful stuff, right? We can do our class-wide intervention. We're teaching our core. We're providing some supplements. Our screening measures are going to be more accurate. We're going to be able to make better decisions about our students who are at risk. And we're going to see future mastery of skills improve as well for our students. Okay, so I like to put this little caveat in because we can't ignore core instruction, right? You all are obviously familiar with your core instruction. Is it something that you feel like you are a master of? You don't need to put yourself on the spot, but St. Paul just recently implemented a brand new math curriculum, and there was, from what I could tell, very minimal training for our teachers, which I don't think is uncommon. I see some people nodding their head like, yeah, been there before, right? And it includes some progress monitoring and some screening measures as well. And it's really tough because, you're handed a curriculum that you're meant to implement, and you may or may not feel comfortable with it. And if you're not comfortable with it, or if you see skill gaps, you might be supplementing with things, and that can impact the overall effectiveness, right? Well, there are ways to look at this, right? To look at it, and you can tell yourself, with your team, your district, on what kind of curriculum you're using. There are some questions that you can ask in order to evaluate the curriculum. So is the curriculum aligned with Common Core standards? Is it aligned with the curriculum focal points of the National Council for Teachers of Mathematics, NCTM? You can look at your textbooks if you are using those to make sure that there's effective instructional design principles. And I will show you a picture of this book at the end, but Dr. Robin Cotting and others have written an excellent book on effective math intervention, and this is referenced from that, so there are some really excellent checklists and questions to ask as it relates to your curriculum as well. We can also thinking about how do we supplement our content, but we want to make sure that we're supplementing with evidence-based practices, right? Not just something we found at Pinterest, which may or may not be evidence-based, but we want to make sure that it's going to serve our students and serve our needs well. And in doing so, we want to make sure that we're including 45 to 60 minutes of regular core instruction. That's what the research suggests, that our math blocks are 45 to 60 minutes. It would be excellent if our administration allowed us 30 minutes of intervention time, right? I know not all schedules are set up that way, but that's really the goal. And that 30 minutes should be in addition to that 45 to 60 minutes. So now we're talking about 75 to 90 minutes really, right? Because intervention should not be taken away from that. It's different than differentiation, right? So we want to differentiate our core, but we also may need to intervene and give supplemental content here. And then thinking about someone in your building or someone in the district or at Patton or someplace that can collaborate and help work on this discussion training. You're all here, so that's excellent, in support of your curriculum components. We can also think about how we're supplementing our instruction. So how are we using effective instructional strategies to enhance our core instruction? Things like using computer-assisted instruction, for some of these skills, like fluency and word problem solving. We can use cooperative learning groups, peer-assisted learning. That's similar to PALS, right? And we'll talk about that a little bit at the end as well. All right, and then this is just a list of our instructional design, our research-based instructional design principles. So if you're not familiar with these, it's just a blend of teacher-directed and student-centered activities, having differentiated instruction, using explicit instruction to explain primary concepts and skills, incorporating classroom management and motivation, right? We want to have both the content but also the motivational piece in that, and then making sure that we're measuring students' progress using formative assessment, in addition to those summative assessments that might be included in our curriculum. Okay, so now that we've gotten that out of the way, right, we've got our core, everyone's feeling good about that, we can move into our class-wide intervention. So here we have foundational skills, our differentiation time and review. And the goal here, I know I said differentiation is different, excuse the circular definition, right, is different than intervention. And it is, but even within our interventions, we want to differentiate, right? We want to make sure that we're matching student needs to the appropriate skill. And here, the goal is to extend the math learning of students who are exceeding grade level expectations. Are you all here because you're interested in that? Anyone? Okay. Maybe a little. But more often we're thinking about how we can work on foundational skills of students not meeting those grade level expectations, right? Okay. So our goals of class-wide intervention are really to build fluency, and that's the primary reason we're here. So we want to build fluency with those core foundational skills, and we can do that by increasing the opportunities for practice. And I believe I can never say Corey's last name, Peltier? Oh, I'm putting you on the spot. Okay, I'm sorry. We have a session right here today, I believe, on opportunities to respond. So if you're interested in learning more about that, that'll be happening. And we can also think about how we are providing feedback to students, both in amount and type. The second purpose of our class-wide intervention, our goal, is to improve the average class performance, right? So we want to build up that base rate that I talked about earlier. And then finally, embed into the naturally occurring classroom routines. So class-wide intervention, I didn't put this in here, but there's a hierarchy, right, of intervention. And class-wide is really meant to use mostly resources that you have already in your classroom, right? So we want to make this as feasible and doable for you as possible, because then you'll actually feel comfortable doing it and we'll implement it. Okay. I've thrown a lot at you already in the first 20 minutes of our time together. It's flying by. Just with someone nearby, an elbow partner, take a moment and just think about these questions here. Think about your classroom, your building, your district, where you're working. What supports at the class-wide or Tier 1 level are already in place? Okay. How could you enhance what you're already doing to further support students in Tier 1? What barriers do you see, and what would you need to overcome those barriers? So just take a moment, think to yourself, kind of reflect on what your current practice looks like. Share with somebody nearby. Thank you. Wow, what a lively discussion. You all had lots to say, lots of questions maybe. Is anyone feeling like they could share or would want to share out what you're currently doing for Tier 1 intervention? Yes? Okay.
In my district, we do at the bells, but instead of actually reteaching those skills, they give them a worksheet on previous skills and just expect them to hand it in.
Okay.
Whereas they need to take that time and look at taking a skill from the previous year and reteaching it till the class masters it, then move on. It takes 10 minutes, all you need, but they aren't doing that yet. So.
Okay. Great, thank you. I love that answer so much because it'll be a perfect segue to what we're going to get into in a little bit. I promise she's not a mole. Okay. Anyone else doing something that they want to share? Yes.
In our middle school building, our 5, 6, 7 building, we have an hour for core, and then we have about another 20 minutes to do a small group center-based instruction where you either hit your on-level students with a more depth of knowledge within the topic or a previous topic, or you are reteaching those foundational skills. But that's only our 5, 6, 7 building. Our elementary's in a different boat.
Okay. Great, thank you. That's even more impressive that it's carved out into the middle school schedule, because that's even trickier than our elementary school buildings sometimes in finding that intervention. Great. Okay. Well, yeah, this is not surprising. This is what I see in my own work currently in my district, and what I've seen in working with other districts around the state of Minnesota and Wisconsin, that it's kind of hit or miss, right? Sometimes it's happening, sometimes it's not, sometimes it's supposed to happen but doesn't. It's really on a pretty wide spectrum. And so we know that it's important, and I'm glad you're all here because you all believe it's important as well. Well, we have our Tier 1 core instruction recommendations, and so right now we'll talk a little bit about how you might make this happen, right? Time. So I heard someone say, well, it only takes 10 minutes, but I know that nearly every moment of your day is accounted for in some way, right? And so 10 minutes might sound to most people like not a big deal, but it can be hard to carve out those 10 minutes sometimes. So we're going to talk a little bit about how that could look, how you might structure that math block to allow for that additional practice and intervention. So we have our divide, determine, supplement kind of structure. And so dividing our instructional time into warm-ups, core, and review. And in doing that, we can determine our skill gaps. We can look at our data. We can look at the prerequisite skills that our students need to access the core instruction or the grade level standards for them. And then we can supplement our curriculum with high leverage, evidence-based instructional practices, things like peer-assisted or cooperative learning, warm-up activities, and different review activities. And just for those, in case you're not familiar, when I say high leverage practices, those are it's capital H, capital L. So, and those are really just those foundational practices that have been shown to improve math outcomes for students. If those of you are interested, I can share some references on where to find those high leverage practices. Okay. So like I said, we want 45 to 60 minutes, right, for our math block. And with 30 minutes of intervention time, so that leads us to 90 minutes, right? So we can break up our time in this sort of way. So we have time for review, time for warm-up, and time for that core. Oops. And if we look at it as percentages, we have about 63% of our time dedicated to our core instruction, 17% of the time for warm-up and review, let's see, now I have to do the math in my head because I didn't put the last percentage. What does that leave us? 63, 17, that's 80, so 20 minutes, 20%, yes? Oh my gosh, this is a bad sign, everyone. Okay. This is why math gets a bad rap. All right, I'm on the spot. Okay, here broken up, I won't make you do the percentages of that time, right? So here we have how this breaks out. Roughly 15 minutes for our warm-up, 45 minutes for our core, 15 minutes for review, and that would lead us to a 75-minute block in this example, right? So a 45-minute core with that 30 minutes of intervention time, which is divided up between warm-up and review in our core. And then you can adjust, obviously, those percentages based on how much time you actually have. We'll come back to that. Okay, so some questions then when we're thinking about what to target, right? So what foundational skills are essential? What grade level benchmarks are critical? And what are the common errors your class is making? And this might be information you just kind of already know or have a sense for, but I guarantee you have data that could support those hunches or those observations, because if we are good at nothing else in schools, it is collecting data. We are not always good at using the data, right? But we have lots of it. And so if, your school, I will put a plug in for your school psychologist. We are excellent data diggers and we love it. So if you are feeling like you're not sure where to start, those are great people to enlist for support and help in piecing that apart if you need it. Okay. And then we always want to be collaborating and considering what's next. So how many of you have thought to yourself, what do the next grades teachers suggest students have to know? So if you're a fourth grade teacher, how many of you thought, what do they need for fifth grade? Or what would the fifth grade teachers say they need? Good, I see some hands, lots of head nods. Right. Good. How many of you thought to yourself, gosh, I really wish the grade level team below me had thought about what they need for my grade? Some laughs, okay, head nods. Yeah, so this is where that collaboration is really important. We all have access to the standards, right? We all know, we can all look at what students need for the next grade. We all know what students should have had in the grade level before, but we're not always good at talking with each other and collaborating as teams. And so that's really important to be thinking ahead for your students and for the next grade level team, and then also thinking about what maybe they missed from the previous year. Okay. We also want to be thinking about algebra. Yes, even in kindergarten, we want to start thinking about algebra. If we can get our students algebra ready, we know that they have better outcomes in graduation and college readiness, college attendance. Doesn't mean that all of our students need to enter STEM fields. It doesn't mean that all of our students need to even go to college, but we know that if they are algebra ready, then they have more options, right? And that increases and improves the equity in our schools as well. Okay, we also want to be thinking about what aspects of the standards are essential for students to proceed in the curriculum. And I heard somebody talking about reteaching, so consider reteaching a failed unit that's essential for further understanding of grade level concepts. We saw that when students reached mastery, they had a higher probability of mastering future topics and having higher achievement overall, right? So consider reteaching and going back, circling back to those something if your class has not reached mastery. These probably all look very familiar, right? Are these things you would have on your list? Things that students have trouble with? Solving word problems, multi-step procedural calculations, math language, checking work and answers, that automatic recall of basic facts, right? Fractions. The National Mathematics Advisory Panel conducted a survey of over 1,000 algebra teachers, and these were the skills that were flagged, right? So we know that these skills are hard for students, and when they get to middle school, high school teachers are seeing this as well. Well, we can do something about it, so that's good news. We know that focusing on whole number operations in kindergarten to grade 5, including strategic counting, number composition and decomposition, solving problems, place value operations, and explicit teaching of word problems is crucial for later supporting that rational number knowledge in the middle grades, in grades 4 to 8, including operations again with those fractions, decimals, ratios, and percentages, and complex operations like long division and multi-step multi-digit multiplication. So that is beneficial even into the middle grades. We also know that math fact fluency is a strong predictor of math performance even into the middle grades. And so it's definitely worth focusing on and leads to better outcomes in these other skills as well, into fractions. So you're going to see this word fluency again in order to become algebra ready, right? We need whole number proficiency, fluency with fractions, and those key aspects of geometry. So these are all really critical foundational skills, and they start with that whole number knowledge and work their way up into those rational numbers. And again, we see this fluency coming up again and again, right? So kids, to be algebra ready, they really do need fluency. And being fluent with basic facts, having that automatic recall, and being able to just know that 3 times 5 is 15 without having to go 5, 10, 15, or use some other kind of strategy to get there, frees up working memory resources and allows students to better access and use those executive functioning skills and metacognitive skills that are so important for solving word problems, for solving multi-digit multiplication, long division, some of those other complex operations. Okay. So we use our screening data. Can I see by a show of hands how many of you in your buildings or your district you regularly screen students in math? Okay. How many of you use the screening data that you collect? Okay. Pretty good. Okay. So we screen our students, we should screen our students, right? Just like we do in reading. Let's do a contrast. How many of you screen your students for reading regularly? How many of you use that data? Yeah, okay, so a little bit of a difference. We'll get there, But we know that we can screen our students in math, and we can look at these whole number knowledge and their rational number knowledge, and then think about what foundational skills are they missing from that. So if we kind of break it out into these broader categories. Okay, and if I haven't convinced you yet that this is important, I'm just going to put this up here one last time, that students with inadequate whole number knowledge were more likely to have trouble in understanding fractions than students with adequate whole number knowledge, okay? So being able to understand whole numbers, work with whole numbers, is crucial for rational number understanding. So even in our middle schools, if a student doesn't have solid whole number understanding, what do you think we should do? Go back, right? Yeah, work on those foundational skills. It's critical, right? Oh my gosh, I had somebody recently tell me that they weren't worried about math because they could they'd always have access to a calculator. I was like, oh, no. Yes, and still no. Okay. All right. Here's our fluency. Again, it keeps showing up, right? We're worried, we want students to be accurate, but we also want them to be fluent. And those things together will support their word problem solving skills, their pre-algebra skills, and their fraction knowledge. And they independently contribute to the success of this, okay? So both number combination accuracy, so those facts, basic facts, and their accuracy and their fluency both contribute independently to these skills. All right. And by fluency, I don't just mean basic facts either, by the way. I mean not automatic recall of long division, but fluency with those basic combinations can get students more proficient and fluent in solving those more complex operations. Okay, so here's just an illustration of that whole number, rational number connection. So students automatically retrieve 3 plus 4, which is, yay, you did it. Okay, they're more likely to access 30 plus 40, right? 3 tens plus 4 tens, see the connection? 53 plus 24, 321 plus 452, $1.30 plus $1.40, and 3/9 plus 4/9, right? If they know 3 plus 4, it's going to be a lot easier to do these other problems as well. If they're not fluent, they're going to need to direct more of their attention and working memory on retrieving the solution, right? You've seen finger counting, okay? Yep, I did a small math group last year with some third graders. Lots of finger counting still happening. And they're going to experience greater anxiety and avoidance of math tasks, right? If they don't have the skills that they need, I would be anxious too, right? If somebody asked me to do something that was hard. Okay. So, and this doesn't just come from me, school psychologist, researcher. We hear this from cognitive scientists that have shown it to be true, special education, educational psychologists, math educators. So this is kind of across the board. Everybody, a lot of research to support this. And we also know that fluent responding is associated with less effort, so it makes the task easier, right? And how many of your students avoid things that they perceive to be hard? Yeah? Okay. How many of you avoid tasks that you perceive to be hard? Right? Okay. Not weird that our students would either. Fluent responding is also associated with, simplify complex tasks by ensuring students can do component skills efficiently, right? So we can do that. And then just a word on productive struggle. So that has kind of been a buzzword over the years. And what we do know is that it doesn't actually deepen understanding, grit, or problem solving. So it's more important to think about where the student's at and the sort of like Goldilocks rule, and making sure that their materials are matched appropriately to their instructional needs. And having a student, putting a student into this productive struggle can lead to frustration, causes students to develop misconceptions, and struggle with tasks without adequate support can lead to lost instructional time, right? Because you're going to have to go back and teach it anyway. All right, so just an example here. If we look at our commutative property of addition, we know that 5 plus 3 is the same as 3 plus 5. And we know that the relationships, we know relationships among numbers, right? So 6 plus 7 is the same as 6 plus 6 plus 1, which is the same as 13. Saying the same as is intentional, by the way, and not equals, because I could do a whole nother thing just on the equal sign, right? Students have a really hard time with that concept. Then also the multiplicative understanding and estimation, right? So we have here, and then understanding base 10 knowledge. So you can see if you understand that addition is commutative, learning basic addition combination is cut in half, right? 5 plus 3 and 3 plus 5 are the same. It's not two separate facts. They're the same, right? That's just one fact. And we can solve novel problems if using basic rules. We can use things like doubles, number line, magnitude, and other things like that. So it leads to flexibility, right? So if we're fluent, we can be more flexible in our problem solving. Okay. I think we've talked about this quite a lot, right? Important. We want our students to be algebra ready. Starts with those foundational numeracy skills, working on those middle school concepts and getting them ready for high school algebra. All right, this is going to lead us into our class-wide intervention, our long-awaited class-wide intervention. So now you have the foundational background, and I talked about warm-up and review as kind of as a way to conceptualize our class-wide intervention and how to support our students. So you'll see it referred to as that. So for our warm-up and review activities, we want to ask those same questions again, right? What are the prerequisite skills? What are the common errors that students are making or typically make? And what vocabulary do students need? And so here's an example for grade 6. If we're thinking about ratios and proportional relationships, number system, expressions and equations, geometry, statistics and probability, we might look at this problem, right? What expression is equal to the sum of 8 plus s, plus 4? So here's an example. So which one would that be, right? So we have 4 options. And so we can think about how do we provide support for this? Well, we can think about what are some of the common errors. The fact errors, regrouping errors, and strategy errors here. Okay. So one of the common errors could include combining numerators and denominators. Right? You've all seen that before? Yep. Okay. Selecting a denominator, just selecting one, just grabbing one from the 2 that are given. So if you have 1/2 plus 3/8, let's just go with the 1/8. Seems right. Okay. Adding across the number and numerator and applying different operations to the denominator. So adding the numerators, but then multiplying the denominators. That's a pretty common error we see. And then adding together all the numbers to find a sum. So 1 plus 2 plus 3 plus 8, so 14. You all seen these errors before? Maybe our middle school people? Some head nods? Okay. You can think about what you might see in whole numbers too, right? We'd see something similar. I remember as a kid when I started learning addition, I thought we just like squish the numbers together. So 1 plus 2 must be 12, right? We just push them together, right? Like a Price is Right game. Just squish all those numbers together, okay? All right. So we can address these common errors by, again, building fluency. We got our computational fluency here. There are other strategies like checklists, using models, previewing or reviewing vocabulary, and then using data to make decisions, right? We can look at the data that we have on our students and make some decisions. Okay, so we have our math block again, thinking about what we can do in those 15 minutes warm-up. Well, that would be a great time to work on computational fluency. So it could be a great warm-up activity. Okay. So we can do that by thinking about which math facts we want to target. Could be related to multi-digit or more complex operations. Could be related to equivalency in fractions or number comparisons, magnitude comparisons of whole or rational numbers. Okay. So we can start with our guided practice, and this is very closely related to the learning hierarchy. Anyone familiar with the learning hierarchy? No? Some people, big Harry and Eaton fans? Yeah? Okay, no? All right. Jared's going to be doing something, another plug. Jared's going to be doing something on that later today, right? Okay. So I love the learning hierarchy, the instructional hierarchy. It really, I think, provides a practical framework for thinking about where students are in their learning progression and thinking about how we need to match our instruction for that stage of learning. More broadly speaking, we can think about it in this way. So thinking about how do we help students establish a skill? So how do they, that acquisition stage, so how do we get them to establish a skill? I'll take us back a little. So in establishing skills, that's when we're working on our accuracy, okay? So we can't be fluent in a skill if we're not first accurate, in any skill, academic or otherwise, right? So we can't zone out while we're driving if we don't first know how to drive. Just drive without crashing, right? Okay. So we have our teacher-led, our accuracy. So this is where we want to use things like demonstration and modeling, thinking aloud while solving, worked and partially worked samples, and then we can get into our timed practice. So this is where that fluency building comes in. Once our students are accurate, we can start working on that fluency. And really, we want them to be roughly 85% accurate on the skills that we're teaching before we move into that fluency stage. So, so that's kind of your threshold. Okay, if they can do about 85% of the work accurately, then we can start moving into more fluent and automatic retrieval. So that's when we might use things like flashcards. That's where those worksheets come into play. Peer-mediated or team-based learning, that's we can start using technology at that point. And that's really to help students retain and maintain their skills. And when we can start thinking about that timed practice, okay? And finally, with our cumulative review, so that's really that enduring and applying, so that's our later stages, right? They're accurate, they're fluent, and now we can help them think about how they can integrate their previously learned skills and concepts and start to generalize them through gameplay, challenge problems, or interleaved practice. Okay, so again, 10 minutes a day. See, I told you, it's like you're had you planted in the audience. All right, so 10 minutes a day is really our target. It could be more, 15 minutes would be even better, but 10 minutes a day. And I know I just said 85% accuracy, but at least 80 to 85%. There's some mixed recommendations there. We can use technology, right, and cooperative groups, response cards. So there's some technology like extra math, personalized learning, Dreambox, Spring Math. Spring Math is an excellent fluency building intervention. Gives you all the probes, all the worksheets that you need, gives you the assessments and ways to look at the data. Okay. We also want to make sure students have those backup strategies. So when I talk about automatic retrieval, I'm not saying that we just teach facts in isolation, that we just want kids to memorize the timetables. That's not at all what I'm suggesting, but we do want them to get there, okay? So on the way, though, we can teach them backup strategies. So, you know, if they're presented with a problem while standing in front of a large group of rooms, they can take a breath and pull back those strategies in case they don't just right away know 63% plus 17%, right? Okay, so we do want them to have backup strategies like counting on, doubles, near doubles, 10 facts, make 10 first, those sorts of things. And again, those commutative and distributive properties as well. Okay. So this is probably intuitive to most of you, or maybe you've seen it play out, but I wanted to put it up here. So we have our pathway to automaticity, and it starts really with that counting on. And this is our least efficient and least effective strategy, right? If we're given 3 plus 5, and we have to go 1, 2, 3, 4, or 1, 2, 3, 4, 5, 6, 7, 8, right? You already saw, I know what 3 plus 5 is, and even I kind of made a mistake. right? So it's not always effective. There's more room for error. You're using a lot of working memory and other cognitive resources for that. So we might move into something a little bit more efficient, like counting up from the first addend. So if we have 3 plus 5, we might say 3, 4, 5, 6, 7, 8, right? You've probably seen that quite a lot. But then, once we start understanding our numbers a little bit more and the commutative property, then we can say, oh, we're going to start with the larger addend, right? That's even more efficient. So if it's 3 plus 5, now I can say 5, 6, 7, 8. I see lots of head nodding. I feel like this is something you're all seeing a lot, right? Okay. Yeah, and then we can get into our decomposition. So if we have 7 plus 8, okay, well, I know that that's the same thing as 7 plus 7 plus 1, and I know that double 7 is 14, so I can just do 14 plus 1, right? That's a little bit more sophisticated, a little bit more efficient. Oops. But then finally, our mental retrieval, that automatic retrieval, and just knowing what 7 plus 8 is, and just knowing what 3 plus 5 is, without having to use any of those counting strategies, is ultimately going to be our most efficient and effective strategy, right? So some people talk about automatic retrieval and fluency as like a separate thing, but to me it's part of that continuum, right? It is a strategy. Just being able to recall it is a strategy, just like looking up here and knowing that that first word is strategic without first having to sound it out, right? You can sound it out if you were taught using a phonics-based approach. You could sound out that word. You could apply the rules of language and to reading to figure out what that first word was. If you needed to, that's your backup strategy, right? But your most efficient strategy is just to look and say, that word is strategic. And that's really what we're building toward for math. We want kids to have the building blocks. We want them to have those backup strategies, but ultimately we want them to just have it be easier to just know that 7 plus 8 is 15, instead of having to like go through all the counting and thinking about the doubles and all of that kind of stuff, right? Okay. So we can use some different strategies and interventions as well to help support this. We can use things like cover, copy, compare. This is I love cover, copy, compare for math, but I love it generally because it's a really flexible intervention. We have good evidence to support its use in a variety of math tasks and concepts, and even for spelling and other things as well. So it's a great intervention to have at your disposal and kind of be thinking about. But cover, copy, compare works in this way. So we have a column of worked examples. So it's hard to read here, but we have 9 plus 8, and it shows the answer is 17. And we have students study the problem, right? So we have them say 9 plus 8 is 17. They cover it, and then they copy it from memory. They have to write 9 plus 8 is 17. So they rewrite the problem. Then they uncover it and compare their work, okay? Did what I write match what the worked example was? And there are different variations of this. This is one way to do it. You can also use it for fact families. So here we have our fact families. We have 6, 7, and 13, right? We know those go together. And so we can have, and here you have 2 tries, right? So if you don't get it the first time, you don't erase, right? Mistakes are okay. We uncover, we study again, and we try a second time, okay? And then we can also use it for more complex problems. Here we have multi-digit addition. And you can see that there are some prompts there for the regrouping and where that might happen. And so now students aren't expected to know and to rewrite that whole problem, but rather show the work. Yes, question? Yeah, that's a great question. So the question was, what if a student can recall it and it has the answer memorized, but can't necessarily explain why, right? Explain sort of the concept underlying it. I would say yes, that's okay. And we know that concepts and procedures, that process is not linear, right? So concepts don't always precede procedures or that fluency. And for some students, learning the procedure first helps support understanding of the concept, right? It's reciprocal. And so I would not stress about that if a student does it, but I would note it and think, okay, how can I support their conceptual understanding then, right? But yeah, that's a great question. It's a similar concern we have in reading, right? When we have those word callers, we want to make sure they're understanding what they're reading and not just reading. Yep, great question. All right. So we also can use explicit timing, and by the way, these are things that you can use with your whole classroom at the same time, or in small groups, or individually, right? It's really flexible. So this could be something that everyone's working on at the same time, and maybe you're differentiating which worksheets students have based on the skills that they are working on, but it's something that you could do as a whole group. Okay, so explicit timing, this is timed practice, right? And here we have addition facts, single-digit addition facts. And so here's where there are various procedures and recommendations for doing this, but you might work for 2 minutes, bracket off where you are, check your work, move on for the next 2 minutes. Sometimes people will take a very narrow set of facts that they want to learn, study them first, practice them first in an untimed way, and then do a timed of just those targeted facts. So there are different ways to do it. You can also do it where you're having them fill in the missing addend, right? So here we have blank plus 8 is 16, so that requires a little bit more flexible thinking. So that's another way to do it. We can also do it with more complex problems. So once they're fluent in those basic facts, we can move into more complex addition, for example, here. And I have probably the best news all day for you. These sheets that I'm showing you are all available for free at the Measures and Interventions for Numeracy Development, this website here, Mind. And these are all evidence-based approaches, evidence-based interventions. And so they're great. There's tier 1 here, the facts on fire, skill remediation and intensive intervention. And yeah, it's great. So the worksheets are already there. They're built. You just need to figure out where your kids are at, what they need, and then hit print. Okay. So we also have peer-assisted learning steps. So this is really, we have an 8-step process where you're selecting an activity, pairing students, you're providing some background, and this could be something where you're using materials like Cover, Copy, Compare, right, to help support this learning. But really, you're assigning students to work together, similar to PALS is for reading. Lots of benefits to doing peer-assisted learning. Students scored higher on NAEP when they engaged in this peer-assisted learning. Again, we can help build up those base rates and engage all of our students in that work. Okay. And another benefit is that peer-assisted learning has actually been researched on students that are non-white middle-class students, right? So much of our intervention research is on students who are white and middle class, but we actually have good support for peer-assisted learning with students of color and in different geographic areas, excuse me. Also helps with social skills. So, post-COVID, all of our kids still need a little work on that. So that's another benefit, right, of peer-assisted learning. They're working on the academics and they get a little bit of that social. Self-monitoring, yes. Mm-hmm. Yep, great question. So there are different recommendations for it. The way I like to do it is you sort of rank order your class on whatever skill you're working on, divide it in half, and you take the highest high student with the highest low student, second highest student with the second lowest student, okay? And you also want to be considerate and mindful of who those students actually are. Will they work well together, right? And some of those other dynamics at play as well. Yep. Okay. Students with math, right, we remember they struggle with some of that those metacognition skills and executive function, so this can help support that. Thinking about a self-monitoring checklist. I imagine you're all using different math models. Yes, maybe? Math models can also help support in that acquisition stage, right, where we're working on developing strategies. Thinking about our vocabulary, also important. And here we want to give simple, direct language, provide examples and non-examples so that students can see when what is commutative property and what is not commutative property, so they can really see that contrast. And then finally, we always want to use the data we're collecting. First, we want to collect it, and it sounds like most of you are collecting it, and I do, like I said, we're really good at collecting data in schools, but we want to actually make sure that we're using it. And so, not only providing those periodic assessments, but thinking about what can peers do, what is the expectation, what are the standards, how are they working toward those goals, instructional goals, how are they doing on those prerequisite skills, are they making progress, what are they missing, how are they connecting that prior knowledge to those new objectives, and then thinking about how we can give feedback and correct those misconceptions as students are learning. Okay. So this requires a lot of good modeling, right? So we need to give students time to show and explain their work, and this can be done through whole group responses, turn and talks, and partner work. Can be done in that peer-assisted learning or cooperative learning, and then also written responses. Again, we have to be good modelers of these skills or this expectation, so students know how to do it, what to do it, and you don't have that one student who's always very eager to share their answer, right, calling out before others have a time to work. Okay. I think I may have been a little bit ambitious in what we covered today. It's okay, I'll just have to come back. Okay, so we have kind of talked about this already, right? So I'm going to, let me see. I'm going to actually skip us ahead to our progress monitoring briefly, and then I'll take time, leave some time for questions. So with our progress monitoring, we want data that will allow us to estimate rates of improvement. So how quickly are students learning the skills that we're teaching them? How quickly are they acquiring those basic facts? It helps us compare the efficiency of our different forms of instruction. So how well is our Tier 1 intervention working, right? If we have a class-wide problem where our triangle is inverted, right, and we have so many students flagged as at risk, we want to be efficient with our intervention efforts and doing class-wide work. We want data that's going to allow us to identify students who are demonstrating adequate progress and those who are not, and determine when an instructional change is needed, right, or help us hypothesize potential sources of need, okay? So these are the recommendations, really. So those students that we would call borderline risk, right? Those students that maybe have some missing skills, we can think about, every other week, every 2 weeks, or even monthly. But when we get into Tier 2, and I would say even with our Tier 1 intervention or class-wide intervention, we want to be gathering data weekly. We want to be looking at how are students acquiring skills each week so that we can act on it, right? We want to be able to be nimble and flexible with our instruction and make adjustments if we need it. It's also important if you're doing peer groupings because you want to see how students are progressing and make sure that the peer matches, the peer tutors are appropriately matched, their skill level. But this can be hard for a number of reasons. One, aligning our measures to the content or instruction. Sometimes those measures aren't always easily available. They're not always the most sensitive to change. And it can be difficult to distinguish it from other classroom-based or diagnostic assessments that we're using, right? We want to have something that's a little bit different than that. And then finding the time to do it, the frequency. But we can look at a few different things. So we have our general outcome measures and then our curriculum-based or mastery measures. Our general outcome measures, those are the measures that help us know are students progressing toward the grade level content and what it is that we want them to know what matches the standards. It can be consistent with our screening tools. But then we also have our mastery measurement. So these are related to the specific skills that we're teaching in our intervention. And helps us measure that mastery piece, right? So we have our general outcome measure for math that could include concepts and applications. It might include some fluency, probably has some word problems. It has things from all of the strands, right, of the standards. But then our mastery measure would be that very narrow thing that we're working on. So if we're working on fluency, fact fluency in our classroom, or fluency with more complex operations, then our mastery measure would look just at that, right? So we could say, okay, are they mastering this complex operation? Are they becoming more fluent and accurate? And then our general outcome measure can say, and are they transferring those skills to our grade level content? Our mastery measure may or may not be at grade level, okay? In fact, it probably will not be. It'll probably be below grade level. So if they're in third grade, our mastery measure will probably be more consistent with like a first, second grade level. And then these are just some resources for finding different progress monitoring tools if you are not already using something in your district. The National Center for Intensive Intervention, just another plug for that, is an excellent resource for finding, they have some really great math content on there right now, and lessons and thinking about how to structure your math content and intervention. And there are also the tools to find progress monitoring and screening tools as well. Okay, so to wrap us all up, in summary, we covered a lot, but running an efficient and effective math block really does require us to, one, identify critical prerequisite skills that we're missing, determine needed vocabulary terms, identify those common errors in the instructional material, include warm-up activities and classroom practices, and then make sure you're embedding time for review. And then here are those resources as promised. So we have, I'll just briefly touch on them. So the first one is the evidence-based intervention network from Mizzou, the University of Missouri. And this is a great source for aligning not only skill, but stage of learning. So it's really structured around that learning hierarchy, instructional hierarchy. Intervention Central can be a goodie, but an oldie. So that one's been around for a long time, but can still have some useful things there. Here's the Mind website that I mentioned earlier with those cover, copy, compare, and explicit timing resources. The Science of Math is an excellent group, and I'm saying it not just because I'm a member, and so is Jared and other members of your patent team. There's also the National Center for Intensive Intervention, and then the What Works Clearinghouse, which is from the Institute for Educational Sciences. And I mostly like the What Works Clearinghouse, not for looking up evidence, although it is excellent for that, but they have some really great practice guides, they're called, and it does a really nice job of like summarizing available evidence and research and thinking about what practices will work well. And then here are just a couple of books that are also useful. Okay. All right. With that, I will stop talking, and we have about 4 minutes for questions. Yes. Okay.
You have all of your references on the slide too. I just was trying to chase your citations and couldn't get them all.
Yes.
Do you have them somewhere?
I don't have them listed here, but I will share the PowerPoint. Okay. Yes. Yes. Yeah, so there's a question about the next presentation. So the next presentation I'm doing will be focused more on tiers 2 and 3 and intervention for fluency. Any other questions? Okay, well, with that, thank you very much for coming. Have an excellent conference.